Hello and good time of day to you. The parts you can see here have been sent to me by someone who purchased one of the lower RAM replacement modules as part of his efforts to get this ZX Spectrum working. Unfortunately, he wasn't able to, so I've agreed to have a look at it. I've got the main circuit board, it's an issue 3B, and the RAM replacement module here in this separate bag. It looks as if something's happened to some of its pins since I last saw it, particularly these ones here. I wonder whether maybe it was soldered in place before being removed and these sockets fitted. Don't think any serious harm has been caused, although it looks rather as if, on these two end pins here, perhaps the PCB pad or through-hole plating has been damaged. I'll have to have a closer look. I've examined this circuit board through a magnifying glass, and it looks as if for at least a few of the pins, particularly these two here, and perhaps one or two over here, the PCB pad surrounding the mounting hole of the pin looks as if it's at least partially been pulled away from the surface of the board. I'm going to perform some tests to see whether the damage has broken any connections and so would cause this module not to work. These probes are connected to a multimeter in its continuity test mode. I know this corner pin here is the 0V connection, so I should be able to find that in many places on the board. Let's try one of these vias. It's a little bit surprising because the pad around that pin in particular looks to be rather badly damaged, but there's a good connection there. Follow this trace here. It's fine too. I know this end pin here is the 5V connection, which appears up at this via. So there's no loss of connection for any of those pins along that end. I will test the rest and then I'll plug it into a known good spectrum to see whether it works. Here's a spectrum that I often use during the testing of the RAM modules. It's fitted with an early experimental version of the lower RAM replacement module, but as you can see it works. So I'll switch it off and fit the returned module and let's see whether that works. It hasn't gone all the way into the sockets at this end because of some rather large blobs of solder on the pins, but hopefully that'll be making contact. Let's switch it on. That's not so promising. It's not what I'd expect to see if the lower RAM were completely absent or there were a serious fault. If the problem is just due to a poor connection, then usually gently jiggling the module will cause something to happen on the display. But that's not the case. I think for now I'm going to put that to one side and come back and investigate and try to work out why that's not working. But instead for now I'll turn my attention to the Spectrum PCB that's sent to me and let's see whether that has any faults other than having been fitted with a potentially faulty RAM module. We can see the upper RAM ICs have been removed, probably quite sensibly in an attempt to rule out them as the cause of any problems, and the 416 lower RAM ICs have all been removed and sockets fitted in their place. There's a small jumper wire over here, so I imagine a trace was damaged while the lower RAM was being removed. But apart from that, it looks as if the job was done neatly. I've just noticed a possible problem down here. This thick trace here is the 0-volt power supply, and at this point here, it looks as some solder residue might be shorting it to this thin trace immediately above. I'll take the multimeter again, set it to its continuity test mode, and let's find out. So that's the 0-volt trace there, and this thin one immediately above it. Yep, they're shorted together. That surely can't be a good thing. It should be easy to clear by running a soldering iron over it. It looks as if that's done the trick. Let's check again with the multimeter. Yes, no short. Might be interesting to check what this thin trace here is and see what the impact of that short circuit could have been. It looks as if this trace goes to the rear through a wire here, where it connects to this side of this resistor, which is marked R70. So let's try and find R70 on the circuit diagram. So this one down here is part of the logic that drives the RAS and CAS signals to the upper RAM. Now, if it was the right-hand side that was shorted down to 0 volts, then that possibly could have damaged IC23 because it would have shorted out its output. If the short circuit was on this side, then the impact would have been less severe. But I know from experience that connecting this point to 0 volts still tends to overload IC23's output. I should be able to work out which of these points was shorted. The output is labelled pin 8, and the other point is an input to IC23, pin 5. A trick I sometimes use when trying to track down a faulty upper RAM IC is to connect this point to 5 volts, which is safe to do. This blocks the generation of the upper RAM column address strobe, and so the spectrum should initialize as a 16K model. So I'll bring back the multimeter. This is IC23 up here, and R70 should be connected to either pin 5, this one, which it isn't, or pin 8, this one here, bottom right. Yes, it is. So that's a bit of a shame. That short circuit was shorting out one of the outputs of that logic IC. That could have damaged it. That excessive current when that output was high might also have dragged the 5-volt power supply line a bit low, and that could have led to other problems. So I'll keep that in mind if I later encounter a problem with the upper RAM. But for now it shouldn't matter. Even if that IC is faulty, it should be possible to get this spectrum working as a 16K model. I'll very quickly take some resistance readings across the power supply rails. If you've watched any of my other spectrum repair videos, you'll know this is a test I always do. I normally use my yellow multimeter for that, because I know exactly what readings it should give with a working spectrum. But that doesn't matter. All I need to do is make sure I don't measure any unreasonably low resistances. Connect this probe to the heatsink. This is the 0-volt connection at the lower RAM, so that should read 0. And just check the other power supply rails quickly. That's fine. None of those measurements were unexpectedly low. So I'm going to try powering this spectrum on now. Normally, when I'm repairing a spectrum, I'd replace any and all of the original electrolytic capacitors before doing that, and these certainly look like the originals. However, with the lower RAM removed, there's not much harm that can occur. So I'll switch it on and see what happens. I've got the multimeter ready to measure some power supply voltages should I want to, and the video output of the Spectrum is connected to the composite input of the television. So I'll turn the power on now. The power supply says it's drawing about 330 milliamps at 9 volts, and the display is almost exactly what I'd expect to see from a Spectrum with all of its lower RAM removed. However, there's not the slightest hint of colour in the picture, and that makes me think the voltage converter circuit must not be running, and so I expect we'll find no 12 volt and no minus 5 volt power supply. This should be 5 volts here. Yes, that's close enough. Over here 12 volts, which is measuring 8.2 volts, that's too low. And this should be minus 5 volts. Nothing at all. So clearly there's a problem there. Switch the power off because there is something I can try at this moment, and that's to install a brand new lower RAM module. Because this only uses the 5 volt power supply line. So the Spectrum might well initialize as a 16K model with this installed. Now the picture will still only be black and white because of the lack of the 12 volt power supply to the chroma encoder. But let's see what happens. Interesting, the display certainly is a little bit corrupted, but clearly the lower RAM passed the ROM's initialization test and the slightly distorted copyright message has appeared. So that's a good sign. There can't be too much wrong with this Spectrum now. The most common cause of the voltage converter circuit not working is failure of transistor TR4, and perhaps TR5 as well or instead. So I'll use the multimeter in its diode test mode to make a quick check of these two transistors in circuit. Transistor TR4 is an NPN transistor and its center terminal is its base. So I should measure a forward diode voltage drop between it and the emitter and the collector when forward biased. Which is the case. And no conduction when reversed biased. And our TR5, which is a PNP transistor, and again its center terminal is its base. So this time if I connect the negative lead of the meter to the base, should measure a forward diode drop between it and the collector and the emitter. Which is the case. Now reverse the leads as before. If I was testing this transistor out of circuit, there should not be any conduction in this case. But I know that when in a Spectrum, most meters do show a forward voltage drop. Usually my old yellow meter shows about 1.2 volts here, but I imagine this meter uses a higher voltage on its diode test mode, so that's probably not an indication of a fault. So one more check, there should not be any conduction here, which there isn't. So that suggests, but doesn't prove, that those two transistors are not faulty. So one more quick check I'll make, and that's of the inductor coil. It's very rare for that to fail, but let's make sure that both its windings are intact. That's one, it must be. And the other one, yes. and they've not become shorted together. No, that's showing a very high resistance between the two windings. So again, that doesn't guarantee there's no fault in that inductor, but I think it's very unlikely. So that's a little bit surprising. I was expecting to find one of those transistors faulty. My next step will be to replace all of the electrolytic capacitors, because failure of one of those is another common cause of the voltage converter circuits not working. If that doesn't help, I'll remove transistors TR4 and TR5 and test them out of circuit. I've replaced all of the electrolytic capacitors, but the voltage converter circuit still isn't working, so I've removed transistors TR4 and TR5. I've checked both of them with the diode test mode on this multimeter, and TR5 seems to be working. However, I found a problem with TR4. I've connected the meter across its base collector junction, and that's showing a voltage drop of about 0.6 of a volt. That's what would be expected. And I should see about the same if I now connect the meter across the base emitter junction. However, in that case there is no conduction. That's slightly unusual because when TR4 fails in a spectrum, it usually goes short circuit between its base and emitter, but it's perfectly conceivable it could fail permanently open circuit as this one seems to have done. So I will replace this with a new ZTX 651 or 653. I know I've got suppliers of at least one of those types, and hopefully that'll solve the problem. It's a bit annoying the faulty transistor didn't turn up when I tested it in circuit. However, I think I know why. Here's the diagram of the voltage converter circuit. This is transistor TR4, and when I was testing it to see whether it would conduct when its base emitter junction is forward biased, I had the meter connected so it was applying a voltage across its base emitter junction with the base more positive than the emitter. However, it's possible that in some situations that can also forward bias the base collector junction of transistor TR5. If we follow the circuit path, we can see that TR4's base is connected via this inductor winding, this resistor, and this resistor to TR5's collector, and TR5's base is connected via this resistor to TR4's emitter. So if the multimeter produces a sufficiently high voltage in its diode test mode, it can forward bias TR5's base collector junction and make it look as if TR4's base emitter junction is conducting even when it isn't. Now I suspect that my old yellow multimeter doesn't produce a sufficiently high voltage for that to happen, so perhaps I'd best go back to using that one when I'm testing the transistors in a spectrum. Rather than discarding all of the electrolytic capacitors straight away, I performed some tests on them for the sake of general interest and to see whether replacing them was certainly necessary. I used a multimeter to measure the capacitance of each, an ESR meter to check the internal series resistance, and finally I connected each across a 15-volt power supply with an ammeter in series to measure the leakage current. Here are the results. I was surprised to find that many of the capacitors had a capacitance much higher than that stated on them. This is particularly surprising given that normally the capacitance of an electrolytic capacitor falls as it ages. I suspect that quite a few of these started off with unusually high values. None of the series resistance measurements are unreasonably high, and I wouldn't have expected those to have caused any problems. And in fact, I don't think the unusually high capacitances of these would have caused much of a problem in a spectrum either. However, the story is rather different when we look at the leakage current results. For quite a few of them, the leakage was unreasonably high. It's too high certainly once it's measured in milliamps rather than microamps. And in fact, during the test, a few of these became warm. So I think I have to conclude that quite a lot of these capacitors were in a poor state of health, and it was quite reasonable to go ahead and replace all of them. And certainly that's what I recommend you do with a spectrum if it still has all of its original electrolytic capacitors. I've refitted TR5 installed a new transistor for TR4, and replaced the power input connector because the old one was corroded and causing an intermittent connection. Let's see whether the voltage converter circuit works now. Straight away I notice there's colour in the picture, so that suggests the chroma encoder IC is receiving its 12 volt supply. This here is the 12 volt rail, and indeed 11.7, that's close enough. And this should be at minus 5 volts, minus 4.35, maybe slightly higher than would be ideal, but I think that should be good enough. Let's fit some lower RAM and see whether the spectrum will work. This is the brand new lower RAM module that I used before. And the computer's initialized, but there's a odd, slightly blue tint to the picture. And while I can see this Sinclair copyright message, it's not complete. It has a number of pixels missing. Now, possibly this could be due to a problem in the video circuitry, but I don't think so, because it very definitely is the case that individual pixels are missing. It's not a general corruption or fuzziness or interference on the display. That's a bit puzzling. I'm not sure what's causing that, but I've got a bit of a suspicion, so I'm going to try replacing a component. And that's the ULA. As it generates the video signal, there's a chance it could be responsible. Now, it's a fairly reliable IC. I don't find it to be faulty in most spectrums that I repair, but I have come across a number of faulty ones before. It was firmly in that socket, but there it is out. I've got another one, also a 6C001E-7. Let's try that now. Well, I think that's confirmed. The previous ULA was indeed faulty. We've now got a good clear picture. The background is the white colour it should be, not blue, and the copyright message is complete. So I suspect this is now a fully working 16K spectrum, though I need to make a few more tests to verify that. Here's the lower RAM replacement module that was returned with this spectrum, and because it had suffered some damage to its pins, I've removed all the pins and cleaned it up so I can have a closer look. And it seems the only significant damage has happened on the underside, over here. This pad has completely gone, and some of the adjacent ones are damaged, but the remaining parts are still connected to the trace. And this one on the end is connected on the top only, and there's still a pad there. So I think it will be possible to fit new pins and have them all make a good connection. I fitted new pins to the RAM module, and that did seem to allow it to be pushed down more firmly into the sockets. However, it hasn't helped. The spectrum still starts with the central area of its display all black as before. I made some continuity tests to verify that every pin on the module while it's installed was connected back to the appropriate point on the ULA, and that was the case. I also checked with an oscilloscope and made sure that the logic inverter that drives the clock input to the address latch, that's this thing here, that's the logic inverter, that's working properly. So I can only assume that either the address latch or the RAM has failed. I know it worked at one point because I test every module before sending them out. This is the first one that's come back faulty. Anyway, I discard that one and continue with the new one that's fitted now. There are a couple more things I want to do to this spectrum, and that's fit sockets for the upper RAM ICs here and verify that it will work as a 48K model. Remember, there's a small possibility that IC23 here is faulty. It may have been damaged because of the short circuit on the circuit board that was down here. Also, I want to do something about the repair that's been done with this wire link. I assume because of a track that was damaged on the surface while removing the 4116 ICs. This is a perfectly reasonable way to make such a repair, but it's not so neat and could be prone to damage, so I'm going to remove the N2 sockets here and see whether I can do a better repair on the surface of the board. I fitted IC sockets for the upper RAM and inspected the RAM type selection links shown on the circuit board underneath the heatsink up here. They're set for Texas Instruments RAM, and the link that chooses whether the upper or lower half of each RAM IC is in use is in position 4. I can't recall which half that means. I'd have to check back to the circuit diagram, but that doesn't matter because I'll plug in one of these upper RAM modules and it'll work with that link in either position. The Spectrum seems to still be working, and the slightly extended initialization time compared to that when it was a 16K model strongly suggests it's working as a 48K Spectrum. If I use this screwdriver to briefly short the leads of capacitor C27, that'll force it to reset, and again we can see that slightly extended reset time. So I'm fairly happy this is working as a 48K model. Of course I'll make a more thorough test in a moment, but now I want to move on to doing a neater job of repairing the broken track beneath two of the lower RAM ICs. After using the desolder pump, and then an ordinary soldering iron and a small screwdriver to loosen a few pins that try to resist removal, these two sockets are free. I can see the broken track here. Just a very small length of it has pulled away. So the connection is broken right here, so that this track is no longer connected to pin 15 of IC13. Now pin 15 is the column address strobe signal, and if the lower RAM replacement module is in use, it connects to that somewhere further over here, and so it will still work perfectly even with this break. But it would be nice to have the Spectrum able to work with individual RAM ICs as well. Despite considerable effort, I just wasn't able to make the repair with the camera in my way. It prevented me from getting close enough to clearly see what I was doing. It turned out that a section of the damaged PCB track was already starting to lift away from the surface of the board, so I had to cut it back to a section that was still firmly attached. Anyway, here's how it is now. You can see the fine wire here that I've soldered onto the end of the track where it was broken. I've then fed it down through this hole. The pad around this hole is completely missing, but that doesn't matter. The corresponding pad on the underside is still present, but even if that had gone too, it wouldn't matter too much provided the same hadn't happened to too many of the others, so that there'd be sufficient mechanical support for the socket. I used a cocktail stick to apply a tiny drop of superglue to hold the wire down at this point here where it passes between these other two holes, to make sure it can't move and short to either of those pads. When I fit the socket, that wire will get soldered to the pin here, and then I'll trim off the excess. Now this is the pin with the repair wire. There used to be another way to make PCB repairs like this. I say used to because it's something I haven't seen for a very long time. It used to be possible to buy circuit board repair kits that contained a selection of copper foil tracks and pads in various different shapes, and they could be stuck down to the surface of the circuit board to effect very neat repairs. With the sockets refitted, let's check that the repair has worked by making some continuity checks. The broken connection was to pin 15, this one here of IC13, and that should be common with pin 15 of all the other lower RAM ICs, which it seems it is. And I'll check to make sure it hasn't shorted to any nearby connections. It seems it hasn't. By the way, all of the lower RAM pins should be common to all 8 positions, apart from pins 2 and 14, which are the data in and out connections. So for example, pin 1 here, which is the -5 volt supply, well obviously they're all connected to -5 volts, but this one here is one of the address lines. Should be common to all of the other sockets, and it shouldn't be connected to any other contacts. It's a bit time consuming, but it's a good idea to make that check for every single pin at every lower RAM socket if you've replaced the RAM with sockets, for example, or made any changes in this area. So, while that repair wasn't necessary for this Spectrum to work with the lower RAM replacement module, it would be necessary for it to work with 4116 ICs, so let's try to prove the point. I've refitted the new lower RAM replacement module and fitted the upper RAM module, and as you can see it now seems to be working perfectly. Of course I'll carry out some more thorough tests to verify all of its functions, but this is where I'll leave this video.